So the end purpose of a capacitor is to convert AC to DC. Is that the
Sorry.
purpose?
No, that's one of the use. There are more uses, but here seemingly your lecture note will be limited to that. Even then, it's very qualitative. So I don't think there will be a calculation on that part. I don't think so. Okay, let's see whether I'm correct or not. So you need to understand the reasons and the logic, but not how to calculate that. The calculation seems very simple. It doesn't seem to be talking about that application.
Okay. C equals Q over V equals E naught A over D. And you know E and Q, E naught is constant. Is area T just levels. Wait, what's the best material for capacitance? Like the best insulator.
I'm not too sure, but I mean, I'm not too sure the exact thing, but a ceramic is very weird, yeah? So the feeling of the bottle, right? The bottle, if you feel, even better, right? Because of the material having this electric dipole, it's just like magnets. So it's a ceramic, but you can see it in your table, right? They just say ceramic and it's around 4,000 something. The increasing the capacity compared to vacuum. You have the table, right? Right. So I'm not sure what ceramic that is made of. Is a very specific thing though. You cannot just use your plate lah. You can't just use it.
So the ceramic would be called a dielectric.
Everything inside there, everything inside there has to have this dielectric capacity lah. If not, then no point. But then again, most things are dielectric. Except conductors lah. Conductor then nonsense lah. You don't put conductors in between the two plates. So it's always an insulator. Everything non-conducting, I suppose. Not everything is direct, but everything non-conducting. Right? Yeah, that's I think the simplest way of saying it for me.
Okay. I think we stopped around here last time.
Yeah, here you have the ceramic, right? Yeah. Oh, now I have 15,000. All right. Very good. Very good. Very good.
But you will not be asked about this in the examination.
Yeah, we probably stop here. Yeah, you try the work example again. It's gonna be not difficult.
Yep. Tried it already, it seems.
Okay.
Yeah.
Right. So if you're okay, then we move to the parallel one. Okay.
Mm.
So I'm just explaining
Okay.
the parallel one in this way that it makes a lot of sense. I'll move up, move up, move up. There, that's it. Why in parallel you C1 plus C2? Move up, move up, move up, move up. This one, this one. Why in parallel you C1 plus C2? This is not what happened in resistor, correct? Resistor, the series is R1 plus R2. So far, so good.
Where is C1 and C2?
And stop. This slide, this slide. You're looking at the correct side. Stop moving. Yeah. There's C1
Sorry,
and there's
my
C2.
headset.
Yeah.
Where is it here?
Look at the left page. Look at the left page. The left page. Look at the left image. Left image. You see the C1 and C2? There are two capacitors there and they are in parallel.
So C1 up here, this is C2.
No. The left image, there is the C1 and C2, and the right image is just an equivalent. Look at the left page first. You see the C1 and C2? Left image, left image.
The equivalent would be like this.
This big guy lah. Yeah, that's the big guy.
Yeah.
The big guy, there is no
So there's
C1
C1 at the top and C2 at the bottom.
Right, but the big guy don't
So
have
you're
a separate
saying-
C1, C2. Yeah, there is not. There is not. You're That's not a right way of saying it.
I gotta send off guests.
Sure. Sure. Yeah.
Hello.
Hello.
Sorry, I'm
Yep.
back.
Yep.
Yes, you were saying.
Yeah. So the C1, C2 doesn't exist on the right-hand side. It's combined already. However, what I want to explain is why is it C1 plus C2? It's extremely simple. If you want to look at the Jamboard, still at page 15. Right? So I think it's very easy to understand why. You see that the left plate connected to the left plate, right? And then the right plate connected to the right plate, right? So in a sense, what you did just now is actually correct lah. Actually lah, that's that. Just being finished. Yeah. I mean, when you connect the two plates with it, you just have a larger plate. Larger plate means larger bottle. Larger bottle means C1 plus C2 done. I'm comparing this with resistor, where resistor parallel is not like that. I'm just saying. Here, capacitor parallel, very easy to understand why it makes a larger bottle.
Yeah.
Okay,
wait, resistor is one.
Exactly like the
resistor is
capacitance.
One over the sum, right?
Yeah, 1 over R goes to 1 over R plus correct. No, that's not correct. That's not correct. That 1 over sum is just wrong. 1 over sum is just wrong. Is 1 over equals to 1 over plus 1 over plus 1 over plus 1 over. That's wrong. That's wrong.
Oh.
Right. That's wrong. Okay. Right. If parallel. And you shouldn't be confused, is what I'm trying to say. You do not want to be confused. If you don't want to be confused, why don't you just put it on your note? Not here. You don't have to write down here. Like you don't like Jamboard as your note, might as well just go to the your PDF lah and write there. The reason I go to Jamboard is because I cannot annotate. If not, we would have probably not used Jamboard. So you might want to write here so that you don't get confused in exam.
Okay. Okay.
Please notice that the parallel formula for capacitor is very similar. The series one to the series one is like this is the reverse with resistor. Look at that. Series parallel, parallel series. Just don't want you to get confused.
C series. C series kind of funny.
Right, series. This funny thing is exactly like how R parallel works, right? It's like the exact form. Right.
So C and R are kind of like weirdly related.
Weirdly related. I would say currently they are totally in reverse. No? If there's a relationship, that's fine. But they are in reverse, which is again don't want you to get confused.
So R series. Okay.
All right. Okay. So a very short explanation on the series one. Why series? Basically, you're going to reduce the capacity of the bottle. Please write that down. Whatever that formula means, when you series to capacitor, the bottle gets reduced. It's extremely weird to our mind. Please write that down, and I'm trying to answer. I explain it very quickly, and then we'll move on. So one increases the capacity, one decreases the capacity. Why do you want to do that? There are reasons, there are good reasons, but it's weird lah. So at the start, it's weird. Do write that down. Okay. So the reduction is because when you parallel two capacitors, series two capacitors, broadly speaking, the distance between them increase. The distance between the plates actually increase. So, oh goodness me, I have to go to Jamboard again. So you go to Jamboard just very quickly. After this. Okay, kindly go to Jamboard for a while. Okay, you probably need to refresh. Yeah, there you go. Okay. So very broadly speaking, the left plate is the left plate, red, right? Red, very broadly speaking. And then the right plate here, there you go, it will be the right plate here. Very broadly speaking. The middle plate doesn't exist, very broadly speaking. All right? Therefore, the distance increases. And according to the formula, therefore, the capacitance decreases. And that's why when you series two things, the capacitor decreases as you increase the distance between the two plates. Right. Okay. But what I'm trying to say is I'm just helping you memorize the formula. That's for practical reasons. That's all. Okay. If there is any question before we move on.
No, I don't think there.
All right. Then why don't you write something like this in your PDF, and then we'll move on.
All right.
All right. Okay. Then again, let's move on. If you say. This one is explaining the formula. You can read through lah, if you want to. Yeah, if you want to. It complements my explanation, so it's good to know, I guess.
I don't like this part.
You don't, sorry, you're saying?
I don't like this part.
Okay, let's see, is it mine? Is your voice affected today? It's a bit difficult to hear you.
Sorry, mumbling a bit.
Right.
Yeah. Polar capacitors are the same. Was this just explaining?
Yep, it's just explaining why. Yeah.
What are Kirchhoff's two laws again?
I'm sorry, you're saying?
What are Kirchhoff's two laws again?
What? I can't hear you. Sorry, try again.
What are Kirchhoff's two laws?
Oh, I cannot say the resistance law. Yeah. Why are you mentioning Kirchhoff law? Why are you doing?
It says here, Kirchhoff's second law tells us potential differences across capacitors V1 and V2 must add up to give the EMF is okay.
Why does he have to say that? I'm not sure why he has to say that. But the Kirchhoff law is no. Let me show you in a more familiar situation. I'm not sure why he has to go there, right? Okay, but you probably already understood this. So board again. Let's go to page 16. Very good, right? I'll show you Kirchhoff law, whatever that is, in resistor. You are more familiar with resistor, right? So also Kirchhoff law, right? You have your, I'm sorry, you have your battery here, right? And then one resistor, two resistor. Let's say this is 9 volt, okay? If this is 5 volt, this must be 4, right?
Yeah.
Can this be 3? Just ask me.
No. Well, I mean,
yeah.
No.
85?
No.
4.9? I don't know, 4.1?
Maybe. No.
No, it's more than 9. Okay.
It could be 3.9 though.
Yeah, if the wire eats up the voltage, so that's fair. That means the wire takes the remaining 0.1, no? Right? Because wire also have their own natural resistance, right? And the battery, once we learn, the battery also take up some voltage also, internal resistance. Don't know whether you learned that. Okay. So my point is, that's the second Kirchhoff law in action in battery. So I go to the idealized situation again, 5 and 4. This is your second Kirchhoff law, but in resistor. That's all. Right? He goes in detail by saying that therefore this point should be 9 volt, this point should be 4 volt, this point should be 4 volt, and this point should be 0 volt because this point is 9 volt and this point is 0 volt. That's one way of saying it. Look, there's a decrease of 5 and then there's a decrease of 4. That's where you get your 5 and 4. This is second Kirchhoff law. In action, not in definition. You know this already. Am I correct?
Yeah.
The first Kirchhoff law. First A law. No surprises. I'm going to draw resistance in parallel to demonstrate that you already know. Here's my 9 volt, which means 9 volt battery, which means this point is 9 and this point is 0, right? That's what it means. That means this point is 9 volt and this point is 0 volt. So far, so good?
Yeah.
Now, the Kirchhoff law will ask you, well, what's the voltage here? And what's the voltage there? And also here and also there. This must be 9, right? This must be 9. This must be 0, and this must be 0. So for both resistors, it is 9 volt across for both. If this sounds too mundane to you, because you already know, well, that's my point. So far, so good. If this is new, tell me. If this is unclear, tell me.
It's not.
Right. Now, this is what he was saying. He was quoting this in the context of capacitor. We just read again.
That's kind of stupid.
Well, yeah. But the point is you understand, right? The point is you understand.
Yes.
Right. If you just read through again, you will hopefully see that that's what he's saying.
Yeah, this is the hard part, the charging and discharging.
There you go. Yeah, the curve, right? If they were to apply this in the DC, remember, you're asking, so what's the use, the purpose? Well, this discharging and charging is the heart of smoothing the AC to DC. We talk about that at the start. If they are to use them in that application, means they have to calculate, then it becomes quite a big discussion. From what I see in your slide, they stop short of applying it. So this part will look like some sort of unnecessary trouble or unnecessary complication. Whereas what it was meant to be is to explain how the smoothing happens. They will not connect to them. So far, so good? I'm just saying. Okay. So if this feels like a disconnect, then I suppose that's why. Okay. I'll try to explain as much as possible, right? Okay. So for discharging and charging, I mean, so far at the end, then we start to talk about filling the bottle and emptying the bottle. I mean, I thought that was the purpose from the start, but he waits until slide, I don't know what slide to talk about this. This is not supposed to be new, right? Why is this a charging and discharging? Let me think for a while. Did he do something wrong? Oh my goodness, I don't think he even explained to you the symbol of capacitor. Dude, why is he giving that symbol here? What's going on here?
I think he explained earlier some.
You have never seen on your slide the symbol of flat line and curved line. Never. Good, what's going on here?
Yeah,
what is that? Why does he do that? I'm going to ask you to ignore this slide just for a while. Let me check something here. Why is he doing all this? Right? Okay. Ignore this slide for a while. We'll come back to it. Now this one. Now look at this for a while. Should be no surprise to you that when capacitor is charging, the bottle is filling up, the charge increases. Then when discharging, the charge decreases. That's not a surprise. About good, right? However, it's a curve and the curve turns out to be, according to this formula, a natural in this a natural power right? Why is that so? He never explained. He just asked saying, okay, that's gonna be what's happening. So that curve is the curve of E power something. Why are you here? Right. Right. So that curve, whatever that is, that's the shape of the E power. So the curve shape e power minus t over tau. Whatever tau is a constant. So it's just a number. Right? Tau. That thing is tau. Yeah, I think it's tau. Right. He never explained to you. He just whacked you. Okay, it's going to be time constant, brother. Tau is R times C. Don't know why. There's a resistance there. And why is it important? Also no explanation. So I guess the way they present it is just more formula to memorize.
Yes, precisely.
Constant
Oh,
is
but-
what I talked about back then. Remember when I say, okay, oh, if the voltage variation is around 8 milliseconds, you want the bottle to be around 10 milliseconds, so it's not fully, it's not fully full, because when it's fully full, you will cut off, the current. Then you something like that. So this is where the discussion becomes more quantitative, but it doesn't seem to connect. So that's all I can tell you right now. That's all I can tell you. That how is very important, and that how he doesn't present it. He doesn't do justice, right? Okay, so yeah, I don't know.
Just like that.
Really, the graph that you're seeing is the graph of the e power. He doesn't, I'm not sure if he is even explaining that. That graph is the graph of the e power.
Okay.
The Q naught is the starting charge, and the T is the time. Yeah, yeah, I don't know. What else can I think? Right. That's it. See? Discharging, charging, still the same formula. Could you just go down? Is this the last line? Okay. Okay. Wait. Up. No, up again. One more. This one. What does he want to say? For now, never mind. For now, never mind, because I don't think he intend to apply. Right, never mind. Let's go to the next slide. No, next slide. Next slide. The point is, with this new formula, the charge, the current, and the voltage will vary, right? Does that make sense to you? The charge will vary with the time. When you're charging, as time passes by, the charge increases. Makes sense, right? This doesn't make sense. Okay. Let me show you a graph. I'm going to share my screen to you, okay? We're going to take them. We have 5 minutes, right? Then we will take a break for a while. Okay, I'm going to share you my screen. Okay. So are you seeing something here? Are you seeing a blank page? So I'm going to give you a very simple graph, right? So graph e to the power of, right? Where's my power? The power of. There you go. Tell me you recognize this graph from your math lab. No physics at all. Okay. So this is just power e. Is a logarithmic. This is a natural power plot, and the graph here will never touch 0. So far, so good.
Yep.
Right. Now, what happens when I copy it and put, instead of x, I put minus x? Any guesses before I do it? What happened to the graph?
It flips.
In what way in your head? I'm not sure, but that's how it flips. Right?
About the y-axis.
About the y-axis. Do you notice that the green graph is the, well, which one? Charging or discharging graph? Which one? You can look at it in
Both.
your PDF. Well, I would say that it looks very similar to the discharging one first. Can I say that? The green one. Green one.
Yeah, that's true.
Right. So that's the discharge one. We'll say that I don't see any, what is it? I don't see any charging graph here right now. I don't think the red one is the charging graph. Okay, you can confirm that? Not yet, right? Correct, yeah. So what happens to the charging graph? Let's do something. Should I explain this first, or should I explain the voltage one? Which one should I explain first? Okay, I'm gonna ask you to share your screen one more time. Then we have to end, right? I want to see the last few slides. I want to see where he's taking this. Then I don't have to over explain. Can I do that? All right. You please share your screen.
Sure.
Right. Like even poly students study more of this, but why bother if you're so limited, right? Why bother explaining so little, right? Okay, the last few slides, let me just see the question. Okay, where does he want to take this? That's okay, I understand, right? Moving on, right? Next slide, please. There you go. Oh, okay. Well, yeah, I can understand.
This seems quite hard.
To your good news, it is not. Let's talk about it on the next 45 minutes. All right, you can take a rest as well. Okay, I'll see you in 9:50.
What?
All right.
9:50,
9:50, right?
again?
9:50.
Oh, okay.
You can take a break first. Yeah, I think you need it. Okay. All right.
Okay.
Bye. Anish, I can see you. Can see you. Anish, I can see you. Can you hear me? Anish, I can see you. Can you hear me?
Hello.
Yep, I can see you. Can you hear me?
Yes, I can hear you.
Okay, good. I was watching the clock and you broke your record from yesterday again. Amazing, right? Like it. Hey, today 45 minutes, right?
Yeah.
So we'll start with sorry, my mistake. I want to use the new. Okay. So give me your what is it? Give me your updates first, yeah, for AMAth. This time type it in. You're gonna use the remember the template, right? So today's date is Tuesday. I hope you can find that template and you can copy it immediately. I'll be reading your update.
I have no idea actually.
So what's happening then?
I mean, school starts tomorrow. Speaking of which, is it possible to have the 1.5 hour session on Thursday for physics, and then make it 45 minutes on Wednesday? Because my physics lesson is on Wednesday.
Your physics lesson is
So it's on
Wednesday.
Thursday. It's on Thursday. I mean, it's on Thursday.
But isn't it better to discuss it before, right? That's one consideration, right? Secondly, I can't considering the slot arrangement I have. I mean, if Thursday is physics, then discussing it on Wednesday is a good thing, no?
I mean, I guess we. Yeah, maybe for this week we do Thursday. So because I'm not really sure what I'm supposed to do.
Don't worry. We'll be doing something useful tomorrow. Don't worry.
Okay.
Right. So we'll talk about what we need to do tomorrow and we'll make it as useful as possible. Okay.
Yeah.
Okay, Aditya, I can see you, yeah? So just talking to Anish. So no updates from AMAth lah. So currently nothing that we know can be used lah. Right? No, nothing. Right. Then my proposal is simple. Today we can continue chemistry, right? Or we can do something with physics lah. At least planning for tomorrow. What do you think? Again, Anish, can you hear me?
Yeah.
Right. I was testing audio. Yeah, I was proposing today do chemistry or physics lah. Did you hear that part?
No.
Oh dear. Okay. Okay. That was a very long sentence. Kena cut off, right? So yeah, that's what I was saying lah. That's what I was saying.
Okay. Chemistry or physics? I mean, if you're doing physics tomorrow, we just continue chemistry. We already have the questions in.
Correct. Right. So let's continue tomorrow's yesterday's Jamboard, right?
Okay.
Okay. Let's do that. So Aditya, can you hear me? If you can, please.
Yeah, I can hear you. Yes.
Wonderful. I can hear you clearly also. So, a few new things, right? This is the first time we wait. This is the first time we meet this year, right? Sorry, did I miss it? Yeah, right.
No, I was there last Thursday, but it was just that I mean, we were going to the how to arrange.
Oh yeah. How to arrange stuff. Right. Okay, understood. So let's follow up from there, and then you give me updates. So I want every day we're trying something new, right? I want every day to be a new Jamboard. So today's Jamboard, do you see in your Jamboard screen? I've already prepared a Jamboard with today's date. Can you see that?
Yes.
All right. You cannot edit.
Yeah. Just one sec. It's loading.
Yeah.
I have too many tabs open.
Right. So going to mention. Okay.
Got like 3 school projects open.
Right.
Chrome, so it's like.
If you could close that for now, yeah.
Yeah.
Okay. So, okay, you cannot do anything with that Jamboard because that's intentional. You're supposed to copy that Jamboard. Then other people can use it. Right? You duplicate that, share with me, and then you're going to use that today. Okay?
Okay.
All right, so I'm waiting for your share. Ainesh, are you at page 6? Page 5 yesterday was done, right?
Yes,
Basically,
I'm
it's
at
done.
page-
No? Basically,
I mean,
yeah.
I did some more afterwards, so yeah. Can you just
Correct.
read the last two paragraphs?
Yep, currently reading them. Right. So your I'm going to write down my notes and then okay, that's it.
Okay.
Okay, so I added my notes and then so do you have it shared with me, Aditya? When you have it, you tell me. Yeah.
Yeah, I
wouldn't-
shared it.
All right. Okay, then.
Actually, from next question onwards, maybe one of us uses a different color when you're like writing text in text.
I would love that, except that Jamboard cannot change font color. I would love that. Cannot change font.
I just changed yours to blue.
You can do that. I'm so sorry. Oh wow. Wait. Oh yeah. Oh wow. Excellent. I will do so. I will do so.
Okay, thanks.
Right. We just cannot change the font now, so changing color would be a good idea. Right. So I'll change my top one. Right, there you go. Right. Okay. There you go. Right. Good idea. All right, Aditya. So have you shared with me if you copy it? Okay. So Aditya, excellent. I can now go in. Now remove the word copy off and also remove the page 1 because you no longer need it, right?
Okay.
Right. Secondly, give me your updates. Then I will read them immediately, right? And then we can.
Okay, so there hasn't been school.
The updates is at page 2. So I want to type instead. Then we can.
Oh,
review.
okay. Got it.
Okay. Do change the title first and remove the page first also.
Okay.
Are you okay, Ainesh, with page 6?
I'm reading the question.
Okay.
What is the difference between an electrolytic cell and a simple cell?
Right. Okay. So when you say electrolytic cell, it's a very bad term. So electrolytic cell, electrolysis, no? Simple cell, battery, no?
I see.
Do type them. Right. That's very confusing English. So let's clarify for future. Please type that down. Okay, Aditya, you're typing. Okay. So again, just to inform you, Aditya, if you're typing, I cannot see your typing until you basically exit the text box.
Yeah.
Are you typing something, Ainesh? I'm not seeing anything. Give me something.
I drew an arrow.
Oh, right. Okay, sure, that works. Okay, I will change my text color into blue. Should I use blue? I'll use red. Okay. For the future, my font color will be red. Would that be okay, Ainesh? Everybody will be red. Okay. Let's make it clear.
Electrical energy is used to cause redox reactions. Okay. Chemical reactions. So, energy to produce. Solution because of the negative electron. Oh, I think I've already solved this.
Okay. Of course, tell me the answer, but more importantly, write down your notes. Maybe write down your thoughts. Got it?
Hold on, I'm confused again. What does anode mean?
I know. Good. Okay, let me type that. Let me type that. I should be using this. So I'm so sorry. That's not okay. I'm sorry. I'm experiencing some difficulty. All right. There you go. Okay, Aditya, do click out of the box first and then go in again. At least I can read something. Then I don't have to waste time. Go and type again. Cool, cool. Like it? Like that. So, good, nice. Oh, tomorrow is holiday for you.
Yeah, we have holiday until next Monday.
Life's good. Really? See, Ainesh is saying, what? How come you have such a good life, Aditya? Tell us.
I have no clue. Even my mom's pretty upset that we have like such a long holiday.
Right. A good day then. Okay, so of course people can see my responses, right? But people don't know what, right? Okay, so good.
Oh,
Right. Okay, then I'm gonna explain further. Right. It's important to get it correct, Ainesh. Right, let's take a look.
mhm. Oh, wait, what? Cations are positive. Oh, damn. Okay.
Yeah.
Okay.
Okay.
So that means C is wrong as well.
C is wrong. Anode is the yes. Wait.
Wait, what? What's going on?
No. Cation is a positive ion, right?
Yes.
Cation. So cation are positive ions. Positive ions are attracted to
Negative.
Yep. Positive ions are attracted to negative side of the battery lah, or negative electrode. That's about the same thing lah. Careful there. So are you sure that C is wrong? At least the first part lah. Are you sure C is wrong? At least the first part I believe is correct. I'll put a big question mark here because you haven't learned simple cell, but I believe this is correct. Okay. Get it
I mean,
right.
and also battery is usually the exact opposite of electrolysis. So if C, the first part is correct, then the part should be correct.
It is a reasonable guess. You are correct though. You are correct. It is a reasonable guess. You don't know why, but it is a reasonable guess. Good. Understand. Aditya, understand. Okay. So Aditya, should we be discussing PNC then? Like at least some
Yeah.
homeworks. All right. Then, as per usual, starting this year, yeah, put all the questions you want to ask, like take pictures or whatever, not like, yeah, put it immediately in the Jamboard, right? Then we'll start doing, and I'll start giving you the hint. Okay.
Okay.
If you're still basic, I feel I'll be giving the hints directly. It's more like a chat. I'll be responding. I won't be covering them. When you're more advanced in the topic, I will be covering them. Make sense? Huh?
Yeah.
Right.
So I gotta put pictures on now.
Yeah, so just take pictures immediately of the questions you want to ask. We currently have 25 minutes, so maybe for PNC, 4 questions is more than enough. 4 questions, right?
Okay.
If you have homework, just aim on the harder ones. If you don't have homework, aim on, I don't know, difficult looking question. That's good. Right. Okay. So you have a candidate lah, Ainesh is what you're saying, right? Okay. Okay. So I'll answer your thing again, Ainesh. Right. Hope you read that.
What's it? It's too small.
Okay. Make it bigger. Make it bigger. Let me see how small you can make it to be. Let me see your comfort level. Okay, understand. Okay, got it. Okay, I'll just give you that, right?
Oh, there's words here. Actually, no. Can you? I think just switch it back to the.
Switch back to it.
Oh, like that, because there's too many words for it to be in the caption.
All right, then let's make I'll make it shorter. I'll make it shorter. There we go. Right. Okay, then you can make it smaller again. Like that, maybe.
Yeah.
All
Okay,
right.
yeah,
So if it's too small, just make it bigger. Okay, put your notes here. I'm gonna put yours on the left hand side, right? Then
Okay.
for now, we divide it that way, lah, right?
I mean, I have an answer, so I'm gonna go B.
Yep. So currently, let me just check. Yeah. How come you have nothing here? How come you have nothing here? I just want to know your thoughts here, lah, right? Because you are learning, right?
I mean, because I already know that this one is correct, so I don't need to think about the other one. But that's also correct.
Then at least say that. I think that's important to say for future you, right? For future you. Okay, good. Right. I agree with all your corrects, right? So I've never seen this question before. I'll look at B one more time. Please move on to the next page first, right? Right. Getting shorter and shorter, your work time. Very good, Ainesh, in a good way. Yeah, B is wrong. B is wrong. B is wrong. So, good.
But you said you agreed with all my statements.
I agree with all your checks, and now I agree with your wrong also. That means I agree with your answer.
So B is correct.
Yeah. B is the answer. No? Like B is not correct. I agree with you that B is not correct, as in B is wrong. So therefore the answer.
Okay.
You request for wrong. Yeah, no. It's very confusing when the question is like this, so I just state the facts first. Right. Okay. Right, cool. Cool. So are you having trouble finding the questions, Aditya?
No, I found them, just like trying to airdrop them to my laptop.
By the way, can it be landscape, your video? Can it be landscape? It's
Oh yeah,
right
I'm
now
just like trying to get the questions.
Oh sure. Yeah. No problem. You just do you. You do you. You're in the process. Got it. At the update page, Aditya, if I read them and no comments, you will see an additional icon, right? Would you please a sticker? Would you please just check page 1, just for information, right? That means I've read them, all right? So,
yeah, let's check this out.
So no saving of pages, yeah. Please one question, one page. Yeah? We need to see.
Yeah.
Tell me when you're done.
Okay, I'm gonna go back to the old Jamboard where you explained this.
All right.
The freshman memory.
All right, and go on and add the note to this new one, right?
I'll do that after tuition.
Sure. Anish, okay? Give me something.
Still looking.
What do you want to know?
Just how the difference between the magnesium and copper affects. I know that I know it's related to the reactivity series, but I can't remember what it does.
Yeah, I'll write down. In this case, I'll write down. Make it better, lah, yeah. Make it faster. Who's more reactive?
More reactive.
Yeah, who is more reactive?
Magnesium
Right, correct.
by a long shot.
Very long. So the intention is clear, lah. Therefore,
What's the thing that makes it stop reacting?
where?
Carbon, sorry, nothing.
Right, that's the first hint of the day. Do you have the question in, Aditya?
I tried putting it normally, but it didn't work. So I'm like putting it in on Google Drive first and then getting it on the Jamboard.
Okay. Let's streamline this process, yeah, so that we can do it. Okay. Explain to me, how do you do it? You take picture using?
I took the picture using my phone.
That means normal phone camera or something, right?
Yeah.
The fastest way to do it is to just WhatsApp to me. So you take picture using WhatsApp, it will appear in your web WhatsApp, you copy paste. That is extremely quick. So next time do it that way. Understand?
Yeah.
Okay. Right, I'm gonna rearrange your page a little bit because I want you to use the template. So you don't worry about it. Just see the end result.
Okay. Yeah.
Okay. So why am I rearranging? Because I'm saying that I want you to do it in a certain way, right?
Yeah.
Right. So I'm gonna duplicate this. So I guess the first thing to do is to duplicate and then immediately use it. Okay. So anyway, if you're doing on paper, immediately do the first one, right?
Yeah.
Okay, let me see where you are, right? Then I'll rearrange everything else for today, yeah? Next time, do it better. Good. The way I can reply to you very, very fast. So, Ernest, okay, how many questions do you? How many questions do you have in total? Did you put in?
4.
Oh, okay, I didn't miss anything. Okay, looks challenging enough, right? Good. Okay, another thing I want you to do this year, Aditya. Notice that your camera is not slanted, but your writing is, right? Now, instead of uprighting your paper is in a natural position for you. Am I correct? You don't feel
Yeah.
any discomfort. Now, please notice that the camera, yes, the camera can do that. Thank you very much. So the camera should follow you, not you follow the camera. That makes sense, right?
Yeah.
Right? Then everybody is happy. Good. So now I can follow you using Jamboard. You're at page 2. Just to confirm that you're doing question 7, correct?
Yep. That's right.
Any question, Ainesh?
How is the redox reaction gonna happen?
Okay, one more time. Mg is reacting, right? I'm gonna answer that because those are important, and we never talk about battery pretty much, right? Just so how does Mg react? Thank you. When we say Mg react, you must be able to predict, right? Mg becomes
Consumed.
No, I know it's consumed, yeah, but you do, as a chemist, you don't say Mg becomes nothing. That's normal people thinking. Your chemistry student, Mg becomes
Reacted, so it becomes ionized.
Yeah, so just say Mg becomes
Ionized.
what? What is the result of that?
Or Mg plus.
Mg2 plus better, yeah, Mg2 plus, and therefore immediately as a chemistry student, you notice that this is either reduction or oxidation. What is this?
Oxidation.
Therefore, as a chemistry student, you must think about where's the reduction.
Yes.
So there you go. So where's the reduction?
Yeah,
that is what you must believe.
Yeah, I'm on the same place right now. Where is the reduction?
All right, then list down the candidates, no?
But where would it be? Would it be near the copper?
No, you're absolutely correct in saying what's the position, right? What's the position? And you don't even know what's the guy in the middle somewhere, right? This is like truly exam question. Now, I'm going to pretend that although you don't know anything, let's pretend that reduction can happen anywhere. Let's just pretend that for a while. Since reduction can happen anywhere, your candidate list grow. That's all. You're just growing your list of candidates. So far, so good? So just grow your list of candidates, and then until everything is included, and then you decide. That's all. For now, that's it. Because this is a slightly more advanced battery. That's why I don't want to. I'm pretending that it's a simple battery. I'd like to see a list of candidates.
But so hold on. Isn't it already like we already know that that's where the reduction is gonna go with you?
Where?
Sorry, I mean oxidation. The reduction.
The oxidation must be Mg, right? Must be there, correct? So where's the reduction side according to you?
Here.
Here is where.
Can you not see my laser point?
And if that is the reduction side, does it make sense from the point of view of he has to be a battery? From the point of view of this thing has to be a battery, does it make sense that the reduction is on the other side?
Yes.
Why? This is important.
I don't really have a reason, just that it's always opposite, so on the opposite side.
Yeah, don't say that. Oxidation means what?
Loss of electrons.
Right. And reduction means?
gain of electrons.
right? And therefore, whatever needs power is there. And therefore, it makes sense as a battery for the reduction to happen on the other side.
I see.
Not that that's the right way of thinking, but at least less logical. Like this is a battery, yeah, it should work that way. Like people should design it that way. So fair logic, that's not a chemistry logic. Chemistry logic, we'll explain it another way, like, but I'm fine with your logic. Okay. So if the reduction is there, still list of candidates, please lah, right? List of candidates. Aditya, you don't mind zooming in just a little bit.
Yeah.
Okay, thank you. You don't seem to need my help for. Oh, you're done. Wait, what? You're at question 8 already.
Yeah.
Okay, check the answer, Kiefer.
Yeah, correct.
All right, understand. Right, I'm just gonna copy this. So this is not difficult enough for you. Good to know. Good to know. This is
This
already
is like IG questions.
Yeah, this is already like the first part of the IG question. So good lah, good that you can do it. I'm not saying that it's not good. It is good. So I'm following you to the next page then.
So it says without replacement. That means after you take them out, you don't put them back in.
Yes, that's correct, and it matters.
Okay.
Ainesh, no progress.
Yeah.
You mean you still can't decide? I mean, you have decided that B is at least correct, right? Yeah, but you cannot decide that A is correct or wrong.
Okay, so in order to prove that A is wrong, I need to list out the candidates.
Yes,
Okay.
yes. You are still a bit slow to go there. Rewire your thoughts, please. Rewire.
Yep.
I hope it's obvious that listing candidates is just a normal thing to do lah by now.
It's very annoying, but yes, I understand.
Yes, it is. It is. I agree. But that's because you haven't rewired your brain. Once you rewire, you are at least not annoyed.
If you're saying that TU will never react, why?
Who will never react? I will see you. I am stating that first lah. I'm stating that first.
So it's a fact.
No, they will teach you in corrosion resistance, so slightly different from this. When you connect two metals together, this is connecting two metals together, right?
Mm-hmm.
The less reactive metal will be protected by the more reactive metal.
So CU is just not a candidate.
Yeah, which is a nice thing, right?
Yes.
You would have to list CU because of this interesting quirk. It always happens in any battery.
Then
right?
I don't have to list the candidates. A is wrong.
Yeah.
It's not, is correct. Wait, what?
Tell me what's the reducing guy lah. Please tell me. You still have to learn that.
Okay.
And listing candidates does help, what, right?
You gain electrons.
Cu plus is also 4 minus. Gaining. I'm following you, Aditya. Just copying your. Oh, that's a very yeah. Okay, writing something. Just curious.
Okay, I'm confused now.
Right. At least you have the candidate, right? The candidates are reasonable. So who will win?
None.
What do you mean? Gaining electron one. Gaining electron, right? Your rewiring process is not over. You're misunderstanding things. Something can happen. Who can be forced to gain electron?
Cu plus.
Can you force it? If it gains electron, what does it become?
becomes C.
Yeah.
Becomes
see?
U.
Yeah. No. Does it make sense? No.
No, but I
It does
sort of,
because Cu becomes Cu2 plus voluntarily. So Cu2
yeah.
plus becomes Cu is a forced thing, but possible.
I see. Okay.
Please write it down. You're still stuck here. Rewiring process, please.
Yeah, I think I'm stuck.
Right. Okay. So Aditya, in answering my question, please just type. Then it becomes your note also, right? So I have a very simple question there, right? Okay. So I'm just reading through. Good. Well, that's very good. I'm not sure about B1 though, yeah. I'm not sure, yeah. So I understand. I understand, okay, right. So check out with your teacher. I guess you'll find out. Right? Okay, good. Now tell me your logic with B1.
Because you can only get 4 balls, and only like if the ball has a number 1, 2, or 3 on them, they have more than 4 balls in total. And the ball was number 0, they only have 2. So like that's not like you can't pull out all of them the same because there's only 2 of them, and you need 4.
Correct. So 0 is just gone, lah. That's what you're saying, right?
Yeah.
You'll write it down there.
Then
Right?
out of these 6 balls with the number 1, you gotta select 4. Then out of
So
the
the
5 balls
order.
with number 2, you gotta select 4. And 7 with the number 3, you gotta select 4.
The number of ways. Gotta think carefully about this. Time is almost up, right? Time is almost up. I'm gonna think about this for a while. There seems to be something weird. The 0 one, of course, correct. Okay. Before we continue, just a minute. I'm thinking about this. I know you're stuck. If both of us, I'm thinking and you're stuck, right? Just move on to the next question first. Never waste time, right? Never, unless you're
Sure.
also thinking, right?
Well, I'm thinking, but I'm blank, so
just move on forward. I'll
Yeah.
give a reply here. I understand you're stuck, ma. I'll be here. I'll be helping, right?
Oh wow, part 3 is worse.
Oh, it is. It is. If part 2 is bad, then part 3 will be worse. It's like that one in DNC. So serious question.
So should I just go to the next question?
For now, yeah. I mean, time is up,
Okay.
but please move on forward. Okay, please move on. Okay. So Ainesh, I mean, I take it that you finish the question just before time is up. Correct?
Yes.
The thinking is there. You're just writing notes. Very happy. Yeah, you've been consistently performing well. And today is like I feel you're finishing just before the time, and you're not finished just at 9:15. It feels good, lah. Feels good. Feels good. Yeah, partly because you're starting early, right? And therefore you can finish, but partly is because you're very engaged. And also you're writing notes. Somehow everything seems to click. So really good for you.
Yeah.
Okay. That said, I'll be seeing you tomorrow.
See you tomorrow. Bye.
Excellent. Bye-bye.
Good night. You too.
Yeah, it feels very weird. It feels very weird.
Yeah.
Feels very weird. The problem is the ball is considered to be all the same or not. The number of ways this can be done. 4 of the balls are chosen at random.
Bless you.
But that wasn't me. Oh, it was your senior, Daniel.
Thanks, man.
I did. Yeah. Okay, so Aditya, I'm not sure how to reply yet. Of course, we'll stop here, but by Thursday, you will be seeing some replies already, right? That's why it's
Okay.
good for you to put the question in first, right? Now, if you already done some of the questions before Thursday, put your answers in, right? If that makes sense.
Sure.
Right? Okay. And starting Thursday, also immediately you know what to do, right? You know, Jamboard, new Jamboard, put question, whack. Okay.
Yeah. So if I'm doing the same questions, I do it on a different Jamboard. So,
No need. It's the same question, then just wait, let me think forward.
okay.
No, never mind. We'll talk about it later, right? If it's still the same question, what do we do? But if you have new workings and somewhere stuck, also copy them in, right?
Okay.
All right. Okay. I'll see you on Thursday.
See you, Mr. Phillips. Thank you. Bye-bye.
All right, Daniel. Do share your screen, I believe, and I can be with you in there. I was talking about Desmos. Yeah, I talking about Desmos and the curve. And I'm promising you that,
Hello?
you're back? You're back?
Yes, sorry.
All
I
right.
think I
So,
accidentally left.
no problem. All right. So, I promise you that the questions will actually be easy, right? Then I'll skip talking about, I'll skip explaining the graph. I'll talk about the question immediately. We'll be using the graph anyway, right? Okay, so show me the first one first. Let's ignore the solution. Show me the first one. I'm going to have to screenshot. So please show me the question. Okay, all right. So I'm going to not screenshot the solution yet. You should ignore the solution also for now. Okay. So in page 17, please. Okay, I'm gonna put a graph in. So just a minute. I'm gonna put a graph. Okay, good. So I will answer the question purely using the graph right now. You see a graph in the Jamboard. Okay, try to refresh or something. Okay, now, all right. Okay, so I will explain it this way. Now, obviously, my graph has no 30 volt, right? And also has no 10 volt, obviously. Okay, okay. So, but I am assuming immediately that the y-axis is voltage and the x-axis is time. If this makes intuitive sense, then we'll move on. Okay, intuitively. Okay, right. Also, the one will now be 30 volt. I hope this makes sense intuitively. Now, you tell me where's 10 volt then.
It's on here.
Right, that's around 40%. So I don't think 40% of 30 volt is 10. Right, try more accurately, please. More accurately, yeah, maybe around it, right? I think this is slightly more accurate, so I'm gonna do that, right? Around here is 10 volt, right? Makes sense, right? Now, and for some reason we arrive at whatever 1 point, I don't know, that's 1.18. I know 1.1. 6, I think. Maybe that's 1.16, roughly, yeah? Right?
Mm.
Now, I'm going to give you a very brief explanation on what 1 means. Pretend that this is 1 tau. Remember that you have tau?
What is tau again?
You look at, now you go back to your, go up, the
Tau
first
is
one,
RC.
that thing, like whatever RC is, right? So I'm going to
Mm.
find the slide that explains to you. Go down again, go down. There you go. Yes. Let's stop here, right? During each time interval tau, okay? So remember that the tau unit is gonna be a time anyway. Even though tau doesn't sound like time, the unit will be in time. It's very weird why R times C is time, but time. So he say that 1 tau, the charge will drop into 37%. Let's clarify this. This is dropping 37% or drop to 37%.
Drop to.
Right. So this is a lot of drop, correct? We are reducing it by 63, something like that. Something like that. Make sense?
Mhm.
All right. So let's go back to Jamboard. I'll show you immediately that this makes some intuitive sense. Okay. This 1 tau, not accidentally, look at the approximate number of this. Look at that. What's the approximate number there? How many percent will that be if this is 100%, right? How many percent?
Are you drawing?
Yes, I'm drawing and it takes time to revise. Thank you. Go to 18 immediately. That's a bit annoying. There you go. Yeah, got it. Okay. So I label the 1 tau. How many percent will that be? Roughly lah.
40?
Less than 40, I'll argue. Correct? Less lah, right? Because 40 is this guy, man. That's 40, man, right?
Mm.
So tell me how much less lah. Let's go in detail lah. Is that what? How many? That's 30 something percent. How many percent is that?
38.
37, right? Okay. 37 to 38% is 1 tau. Exactly what your notes say. This doesn't make logical sense, but this is intuitively, that's 1 tau. Okay, 1 tau. Let's go back to your notes and let's see what 2 tau is. Let's go back to your note. 2 tau. You say
Tau is not a constant, right?
Tau is a constant that depends on the R and the C of the capacitor. Right? Whatever that means, there you go. 2 tau is going to be 13.7%. Okay? 2 tau. Okay, let's go back to the Jamboard. Let's go back to the Jamboard.
I'm so confused.
I know you're so confused. I'm asking you to intuit. That's the faster way I can teach you, right? You are confused. Yes, I know. Don't stop using your logic. Stop for now. I'm asking you a very weird thing, right? So 2 tau, how many percent is 2 tau?
17%.
Around there, right? Around 16 to 17%, right? So which is again what your note is saying lah. Again, this does not make logical sense, but there you go. 1 tau, 2 tau. All this from a simple graph called, what is the graph here, if you remember? E to the power of?
X.
No, minus x. That's it. All from that. Right? So your notes will be saying that x will be equal to t over tau, right? T over tau.
Mm.
So there you go. If the time is 1 tau, right? If the time is 1 tau, so this is 1 loop, correct? There. 1 loop, then you get 37%. 2 tau, right? So again, if this is equal to 2 tau, right? So tau over tau, x e to the power of minus 2 lah. Right, there you go, 2, then 16.7%. Just that's what mathematically, that's what it means. Make sense?
Why do we care about the percentage?
Very simple, because at least I'm familiarizing you with the math. Your math seems shaky here. This
But I
value,
don't care about the percentage. Why do I need to
That's-
care about the percentage?
your problem, no? That is your problem. No? If you just understand the math, it's so simple.
So
Because
tau
you
is a
don't-
percentage.
Now, tau is a constant that is here. Now, this thing is time. 1 represents, the time is actually 1 tau. So let me just give tau. Let me just give tau. What do you call it? Tau. A number, right? Because tau is supposed to be.
You're speaking, but I'm not understanding. So tau is a unit of time. So let's say 1 tau could be 20 seconds.
Correct. Or in case
1
20
tau could be
milliseconds.
30
let's say.
seconds.
Millisecond. Let's go for
It could
millisecond.
be milliseconds. Okay, so it could be any number of milliseconds, but as long as you have a set value, then you use that value throughout the rest of the equation.
In the sense that
tau.
because that represents how the capacitor works. That is the property of the capacitor you're using.
And R
is
If-
the
if-
resistance.
R is ohms,
The
C
R
is
ohms.
coulombs.
Right. Coulomb is the capacitor. R is the resistor attached to the capacitor.
And wait, if I remember correctly, coulombs.
C is
Is
not
joule.
Coulomb. I'm sorry. C is not Coulomb. C is capacitance. Farad.
Farad.
Capacitance.
Okay, that's
That means,
tricky then.
yeah. I did say that. C is not Coulomb. C is Farad. Very, very annoying.
C is farad.
So
So
that's
for whatever reason, when you farad times resistance, you get
something important.
time.
No, you have time, which is not time. This is the time constant, the tau, which is for some reason very important in
What is the difference
defining
between time and time constant?
Let me explain. Now, please accept that tau is the property of the capacitor. It depends on the C of the capacitor. See, something like that. Like how big is the water bottle? Oh, 500 milliliters. That's your volume constant. No? So capacitor always have a tau, a time constant associated with how big it is. I guess that makes sense, right? If my capacitance is bigger,
what does this time constant do?
It defines the capacitor. I'm sorry, that's very vague. I'm going to explain it right now. Okay, I'm going to explain it right now. It makes sense that the tau grows as the capacitor grows. Like, oh, I have a bigger capacitance. My tau grows. That kind of makes some sense. It takes more time to fill it, something like that. Okay, but for some reason, you have to include the R. Those reasons are never explained. They just whack you. You got to times R with C. Don't care. That's what you do. All right. So far, so good.
So you're saying tau is the time taken
No.
to fill
time
capacitor.
No. Let me explain. If I have two capacitors, I'm so sorry, I pressed something wrong. Right. Here we are. If I have two capacitors, right? So the first capacitor, my RC is, I don't know, 20 millisecond, right? My second capacitor, my RC is 30 millisecond, right? This will be my tau, correct? The tau of first and the tau of second. Here's the simple truth. Whenever I reach time of 1 tau, it will always be 37%. Whenever I reach a time of 1 tau, it will always be 37% for both. So if the first capacitor, I use it or charge it or discharge it for 20 milliseconds, it will always be this magic number. For the second capacitor, although the number seems different, 30 milliseconds, but it's 1 tau magic number again.
Okay.
That's the math that properly actually describe how capacitor works. Because if you're familiar with the math, that's just the E graph. It's just the E graph. E graph at 1 is always 37. E graph at 2 is always 16 point something percent. It's always like that. Always like that.
Okay.
Okay. So they prefer to talk in terms of how many tau instead of the simple millisecond, because it is more natural, I guess. Natural not for us, but natural in terms of how the physics works.
No, I disagree.
It's not natural to you. Really, it's not natural to you. Because the math is not natural to you. It's not
Why
called,
invent a whole other thing?
because this describes not just capacitor. That's why I keep saying to you, you're not familiar with the math. This describes almost everything that is natural. But maybe they never explain it that way. Maybe they just explain it as something which is for you to do on them, right? Really. This is just curious, yeah. In your math, do you learn differential equation? Sorry, you should be taking higher math, right? You are, right? Taking higher math. Your higher math should reach the end of your integration, right? Should have reached the end of integration, right?
Yep.
In the end of integration, there's something called differential equation. Did you touch that topic?
Yeah.
Differential equation functions are almost always the graph of E, no? Almost always. In integration, they also talk about the differentiation of the differentiation of the EX as EX. There's something special with the number E. They didn't invent this just for capacitor, is what I'm trying to say. Right. So we're going off topic, right? Now, if you cannot accept,
always been there.
It has always been there. Apply to many things, not just the capacitor. Yeah. Apply to many things. Even compound interest, which is totally doesn't seem to be natural at all. Now, however you take it, you can hate it. I'm sorry, you can hate it. It doesn't seem natural for something so natural, right? But it is here to stay. Now, if you don't get the percentage thingy, you have another option. Just do the formula. That means you don't go the explanation route. Just whack the formula. Now, if you want to go through that route, we definitely have time to demonstrate that. Right? Shall we go through the non-graphic method? Shall we?
Okay.
Right. So still the same question. We're just moving to the next page, right? So I'll be using formula only without the graph, yeah. Right. Right. So he gives me the R, he gives me the C. For obvious reason, I need the tau. This one you have to accept. So I need the tau. Correct? He tells me that he wants times taken. Well, I have to remember the formula as ET over tau equals to, well, whatever comes up. There are two boxes. Equals to this box and this box. Right? So far, so good. We're at the Jamboard. Yeah, there you go. See, I just used the formula given to you. Tau equals to RC and Q naught. Something.
Q naught is maximum Q.
Right. And surprisingly, I'm not using Q and Q naught here. I am not. Because these two boxes, oh goodness, it's refreshing very soon. Right. Those two boxes can be Q, can be I, and can be V, depending on the question. That means the Q, the I, and the V follow the same thing. You just have to memorize one form for treating. Right? I am writing something. So obviously, I'm not going to use Q. I'm not going to use I also. I am just going to use V. So far, so good?
Okay.
Now, this box, the box on the right, is always the V initial. And phi, this one is V at whatever time I want. Make sense? They are not the same V. They're not. Okay. Now, do I have the tau? Just to confirm.
Yes.
The R and C, right? So therefore, I have tau. Do I have the V initial?
No.
I have. There you go. V initial. How do I know that's V initial?
Oh, that's V initial, not V final.
Why? Because of course he say charge, but then he switched to discharge. Is this question charging or discharging?
Discharging.
Is actually V initial or V final or V in the middle? What is it? Let me repeat this one time. The capacitor is filled to 30 volt. Nothing surprising. A capacitor has to be filled, correct? If not, then why bother, right? Then suddenly he say the capacitor is being poured out. I fill this capacitor to 30 liter, and then I start to pour it out. Calculate the time taken for the capacitor to pour things out until it is only 10 liter. Make sense so far?
I hate these kind of questions.
If you hate it, we stop. I'm serious, but don't hate
It's
it. Or
a-
rather, but don't hate it too much. Just hate it a little bit.
Alright.
So one more time. Is 30 liter the start of the pouring out, or the middle of the pouring out, or the start?
It
That makes
starts
sense,
from
right?
30
Correct.
and
makes
it
sense,
ends
right?
at 10.
Correct. So do we have this V? Just saying V at whatever time we want. Do we have that, or are we supposed to find that?
Oh, okay, understand.
Good.
Wait,
Then this
so
is the
it's
question mark, right?
10 equals 30
Yeah.
T
Over
RC.
C lah. You put in the RC lah, right? Kan?
The E is a constant also, right?
Natural
What's
number.
E?
Yeah, it's a natural number, which is in your calculator. You're not supposed to memorize it.
Oh,
Just
that
use your
E,
calculator.
okay.
That E, yeah, that E. 2.7 something.
300, 330,000
Times.
times
Can you handle micro?
minus 12, right?
No, micro is -6. Right. And then you're gonna do math at this point. Physics is done.
Number T equals.
What are you supposed to do here in math?
Just math it out.
Wait, you don't know the math?
I lazy
You don't-
calculate.
No,
I know how to do. I know.
You
I
know.
know how to do.
You
I
know
know.
how to use lot. Okay, great. Okay.
Yes.
Then
I know
don't
how
care
to use
about.
line.
Correct. Then good, really good to know. Then done.
Okay.
Done. That's it lah.
Okay.
Okay. It's not second, by the way. I don't think it's going to be second. I think it's going to be some sort of milli or microsecond usually.
Just 80 seconds.
That's very weird. Let me check one more time. Oh no, that's very weird. That's very weird. Let me think for a while.
Let me do the working.
The time
Okay.
constant is clearly not 72 seconds. Do the
Okay,
count.
let me-
Do the count. Yeah, do the count. Oh goodness me. I think. Let me think for a while. No, yeah, I don't think the time constant is 72 seconds.
Let me see.
Do the manual calculation here. 350 times 220 times 1000 times
Oh, it is 72.
-6 -3. Oh, it is. Oh my goodness. It is. 22 times 3.3 is equals to around 66.3. Oh, it is 72. It is 72 seconds. It is. Then my mistake. All right. So, okay, understand. So 80 seconds. Now I'm going to give the graph one last try. Yeah? Go to page 70. So-
Formulas a lot more.
Yeah. So the tau is 72.6 seconds, right? Correct. According to our answer, the answer is slightly above 1 tau, which is what the graph predicted also. Just saying. That's all. Okay. Right. Let's move to the next question. Let me screenshot the next question. Oh, I'm sorry. We haven't answered B. What am I talking about? We haven't answered.
Oh,
Calculate the charge moved from the capacitor in this time. Do you understand the sentencing?
charge is Q, right?
It is Q. Yep. It is Q.
C is Q over V. Right? QV is Q over V.
Yep. QV is equal to C. Yep.
Where is it? That is C.
No, you will see Q over V equals to C, right?
Therefore, Q is C times V. We already have C. Right?
Yep, you do. Oh, this will require explanation. This will require.
V is 20.
20.
V will be 30 minus 10.
I'm not sure how you get that, but okay.
I'm just guessing. I don't really know how to get V.
Right. So seemingly you have two options right now, 30 and 10. Seemingly lah, right?
Or something involving both of them.
Will it work? You? Probably.
Okay. Let's think about it. Is in this time, the time
I don't think it matters. Yeah, I don't think it matters at all.
in 80 seconds, right? 80 seconds, it goes from 30 to 10. Is it 20 volts? With the difference, let's see.
Yeah, it doesn't matter. You're correct. So the initial charge is 30, man. The initial voltage is 30. The final voltage is 10. You want to calculate the move, correct?
Yeah, it's 20.
You're correct. It is correct.
Right.
All right.
Equals answer, which is 4.4 microfarad. Should be microfarad, not microcoulomb.
It should be. There you go. See? Microcoulomb. This C is not the capacitance but the coulomb. Very annoying. But he's correct. It should be MC because it's Q. The unit of Q charge is coulomb, big C.
Okay. But isn't...
Yes.
Oh, it's for coulomb. If it's so stupid, there's one C here and then there's one C here.
No, that 2C is the same. No, that 2C is the same.
Sorry, one C here and then one C here. The Q units is C.
That is stupid.
And the C units is F.
Would you please write that down in your PDF? Would you please write it down? It is stupid. I'm not sure whether I don't think it's intentional, but it is stupid and confusing when you first start to learn it. It's so annoying. Please write down something here. So that when it's time for exam, you will at least know lah.
F if Q is charge equals C. Alright.
Right? Good. Yeah, it is good. Let's look at the next example. Right. Okay, I'm gonna screenshot it. Next slide. Okay. Okay. Let's go to your Jamboard again. Don't look at the answer key, please. Go to the Jamboard. Go to the Jamboard. So, what formula do we need to use? I put the question here again. So just pretend it, right? Calculate the number of multiples of time constant. Time constant. There you go. He will insist to do that. Right. The time constant is your tau, right? Sorry. Okay. From your memory, what are the formulas that might be relevant? Tau equals to
37%.
Tau equals tau equals to formula, not percent. Okay, wonderful. And then you will have the other one. I would say box equals to box, then E minus power what?
T over tau.
Very good. So you have it in memory lah. And then the two boxes will be this, and that, correct?
Mm-hmm.
Do write that down first. Do write that down first. Do some, go through the motion. Write down the T over tau. Thank you. Right. Now the boxes will be what?
In this case,
Sure.
Q.
And both Q, they are different. So the left box is what Q, the right box is what Q.
Q naught.
Right. And then the left box, if you understand that's Q on the time, then that's good lah, right? Okay. Do notice that the question does not give you the R at all, does not give you any C at all. Therefore, the tau is unknown lah, correct? Ding. This is what the question asks for. So of course, we don't know the time. And do notice that the Q naught and the Q is also not given. It's not a mistake in your reading. They are just not given. Right? What the heck is this question doing? It does not give you anything. Is there supposed to be a new formula or something? There's 90%. Well, how am I supposed to fit in 90%? I mean, of course, I know. I'm trying to guide you, right? What are we supposed to do with 90%?
That is a good question.
Right. This is the correct. I'm writing this. So this is my first hint. We are supposed to think about this guy. You didn't miss anything. You didn't. Right? Think about 90% and forget the fact that we don't have R and C. Right? Let's just forget that. This 90% has something to do with the charges, right? Has something to do with the charges, right? Something like that. If you pretend that this is 100, this is pretend, right? This is pretend 100. This is therefore pretend 10, but this is a good pretend. So therefore, notice that 10 over 100 is of course 10%. correct? This is what you end up with. This is how you use the 90%, correct? Good. Now, you don't have any tau, so what are you supposed to do, right?
2.3 times of 10 constants required for capacitor to lose 90% of its charge.
Yeah, so you need 2.3 tau because at 2 tau, remember the magic number of 2 tau? 2 tau is how much? At 2 tau, you're already at how many percent?
37.
10.7%. No, that's the
17.
1 tau. 1 tau is
point something.
37%, right? So your answer seems to make sense at least, right? More
Wait,
than
the
2 tau,
percentage that we remember is across
1
the
tau.
board.
No, just 1 tau and 2 tau. Yeah, it
The,
works
the
every time.
percentages that we said is across the board lah.
Yeah, no matter what the box is, no matter Q, no matter V, no matter I, no matter what capacitor, the percentage hold is a natural law. Huh?
What holds it in place? What makes this law true?
Natural law, or rather by design. No, I'm not sure why the nature
So
is designed
this
that way.
is a pattern.
Yes,
that you
it is a
can-
pattern. You can rely on.
It is a theoretic pattern because in real world
It is.
context, it will not be true.
It will be a variation of this decay pattern. No? This is a decay pattern. A decay pattern is ideal smooth. The real world is a variation around that. That means we just go up and down a little bit. It is very
So very
clear
like
that the pattern
5 to 10%.
less
less
than
than
that.
that.
Less than that.
A lot
or
less.
Very well, like a very. Let me just show you what I mean. Like so, the idealized graph is very smooth, correct? Smooth, right? A practical one will probably just look like a little like that. Not like a stock exchange. You've seen a graph of stock exchange, you go like that. No, this is clearly what's happening, and not just for capacity. It's not just for capacity.
Okay, that's interesting.
Right. One day we will be able to ask God lah if we want to. Hey, why like this one? But the pattern is very simple. So your answer makes sense, right? 2.3 tau. At least it makes some sense according to the percentage, right?
Yeah.
Let's check your note, see where it's going. Going right to the last one. Yep. There you go. There you go.
So it's really just math. At this point, it just gets to a point where it becomes.
It
you
is just
plug
math.
numbers into a formula.
Yeah.
And
It
it
is
just becomes
just
math.
Yeah. Which I think the graph
boring.
and this point. Yeah. I promised that it will be easy, right? I did promise that.
Yeah, you did.
Okay.
Okay.
And
So
don't want to
the-
over explain.
The only formulas I need to know for 11.3 is tau is RC and box equals box E T over minus T over tau.
And the capacitor parallel series.
And okay, capacitor parallel will be C1 plus C2 plus C3.
Yeah.
And then in series, it will be 1 over C is 1 over C1 plus 1 over C2.
Yeah. And then there's still Q, C equals to Q over V. There's still that.
And C equals Q over V.
Right? There's that. Are you
Is
sure
there
you're not missing
anything
anything? You check. You check. Very quickly. And then just nice we finish. Right. Let's quickly check so that you're happy. Admittedly, those are new formulas. Admittedly, right? This one. They never ask for this one, the energy. Anyone? Oh, they did ask like the work example. Fair enough. Right.
Yeah.
By the way, it's half QV lah. Right. So, don't know why it's half.
It's just like that lah.
I was mentioning QV in the general principle of electricity that work is equal to QV. Right here is half low. They did explain, but I don't want to go to it. Right, just half like that.
And
There's this one also.
V over no.
Mhm.
C equals Q over V equals permittivity of vacuum times area over distance.
Yeah, that means the permittivity of vacuum must times something else if it is not vacuum, if it is something, right? So it's better to memorize the last one.
Alright.
Right. I think that's it. I think that's it. They are admittedly easy to apply. Like the hardest one is the one at the last, and you get it.
Thank God.
That's 11.3. Are you ahead of the class?
Yes, very much so.
For the first time, we can formally say that you're ahead of the class. When you were trying to be ahead of the class using the electric field, like it's as if the class doesn't acknowledge that. I don't care. Bye. I just give you an exam. Oh, who cares? All right. That's it for this week. Okay. This getting ahead will run out next week. So next week, give me updates and then we'll just do this. Okay.
All right. Let me see. I think let me just update you on this Sunday.
Yep.
Yeah, should be able to.
Yeah.
But there's a week. There's a week in February where Sunday and Tuesday, the 19th and the 21st, I'm both not free.
Can you afford that?
Could we reschedule on those days? It's still about a month away, lah.
Like, I mean, how can you reschedule the other thing? Right? That's one way to
No,
prioritize physics, right?
Those ones 100% cannot reschedule.
Are you sure you can sacrifice physics for that? You can go to Thursday lah. You can recover half to Thursday, no? I mean,
I spent quite a bit of money on it lah. So
that's your call, okay? That's your call.
Yeah.
Right? So your rescheduling time is on Thursday lah. If you can, I'll see you on Thursday. All right? Okay, I'll see you then.
Okay.
All right. Bye.
Good tuition.
All right.
See you soon.
See you on Sunday. Right? Okay. Right. All right.
Yep.
Bye-bye.
I will continue highlighting and update you.
All right. Bye-bye.